Hello guys, my name is Karabo Sithole and I'm a student from the University of Witwatersrand. I am studying Bachelor of Accounting Science, and today guys we are going to continue with the videos, and today's video is going to focus on application. How then do we change? It's going to focus on how then do we change the theory that we learned and apply it, right? It's all about application in maths. The only way to know maths is to practice it, and only the perfect practice makes things perfect. So let's get right into it, guys. Before I continue, I'd just like to show gratitude to everybody who has shown their support, shown their love. Thank you for subscribing, thank you for liking my videos, and thank you for commenting, right? To all the new subscribers, welcome to the gang. We are the class of asymptotes. We are the untouchable. You know that line in maths that you try to reach and reach and reach and reach and you never touch? We are that. So let's get right into it. As I said, we are going to do an applications session, and we are focusing on sinking funds, balance outstanding, interest portion of the loan, the principal portion of the loan, final payment. What then do you do when there's an interest rate change when you've missed a payment, right? So we have the first example, and the first example is a sinking fund example. Before I continue, I have to acknowledge that the questions I'll be using in this video are not my own, but they do belong to the School of Applied and Computational Math, right? So yes, guys, let's get right into it. So we are told that a company buys a vehicle today for 60,000 rands. So the vehicle that the company has bought today is worth 60,000 rand. And assume that the cost of replacing the vehicle increases by 12% per annum. So 6 years from now, the vehicle is going to cost 60,000 compounded with 12% interest, right? And they continue to tell us that in the vehicle we own now depreciates at 20% per annum. So the vehicle that we buy now, 6 years from now, will be worth less, right? And to find that value, we have to depreciate the 60,000 vehicle with 20% interest. As I said, to depreciate something, when they say that something depreciates, it means that it loses its value over time, right? The car you buy today won't be worth the same 2 years from now because it will wear off as time goes on. So we need to also depreciate the car. So they tell us that the vehicle is expected to be replaced 6 years from now. So in order to purchase a new vehicle 6 years from now, equal quarterly payments are made into a fund that earns 8% per annum, starting 1 quarter from now. If the vehicle owned is sold in part payment of the new vehicle, the quarterly payments made into the sinking fund are equal to, right? So what will happen is that I have bought a vehicle today. It costed me 60,000 rand now, but I need to replace this vehicle 6 years from now, and the vehicle that I bought today will be sold as part payment for the vehicle that I want to buy 6 years from now. So in order to find out how much the vehicle I have bought today is worth 6 years from now, I have to depreciate the vehicle that I bought now, right? And I also need to appreciate this vehicle to now understand, because there's inflation, right? The prices will increase. So to find out how much this same vehicle will be worth 6 years from now, or will be sold for in the market 6 years from now, I need to appreciate this 60,000 vehicle with the 12%, right? So whatever amount you will sell it for after depreciating it will be paid in part payment for the new vehicle that you will buy 6 years from now. However, that amount won't be enough. So you also need to make deposits as time goes on before that 6 years so that you can buy that vehicle. So normally you would also have to maintain the vehicle that you bought now. So you would have to maintain the 60,000 vehicle. But in this particular question, we do not have any maintenance that is made to the car. So we have 0 withdrawals, right? So basically, as I said, this 60,000 that you have right here will be appreciated with the 12% per annum. Hence, we said 60,000, 1 plus 12% to the power of 6 because it is 6 years. My I is matching my N because my I is 12% per annum per year and my N is 6 years. So they are both in years, right? So that's what you just need to make sure of, that your I matches your N in terms of the periods, right? And then the old machine is worth 60,000 now. I will need to depreciate this machine. You still use the same compound formula, right? But you just put a negative. So you will have 60,000, 1 minus 20% to the power of 6 because it's in years, plus the deposits that you will have to make. So we have PT, quarterly deposits, and we want the future value of that. Hence, I put an S. And remember that there are 4 quarters in a year. So if I'm looking at 6 years, it has to be 4 times 6, and that is 24, right? And then I will have to change this 8% I that I'm given to a quarterly interest rate, I4. Because my payments are made quarterly, I cannot change how my payments are made. So now I have to change my I using the equivalence formula so that everything works together, right? So that's exactly what we are about to do. So the equivalence formula says 1 plus in to the power of n is equal to 1 plus im to the power of m. So 1 plus 8%, this 8% per annum, because it is per annum, you are compounding it once a year, right? So that's why I put to the power of 1 equal to 1 plus I4. How many times are you compounding it per year? If you are compounding it quarterly, 4 times a year. So you raise this to the power of 4. So I4, you solve this using your calculator. Let me just show you. 1 plus 8%, right? Raised to the power of, remember there's a 1 here. Divide by this 4. 1 divided by 4 minus 1 times 100. So I get 1,94265, etc. Goes on and goes on, percent. So I will store this under A. Okay, cool. So let us now continue with our question. So I have the 60,000, right? Remember the formula that we had in the previous page? Sorry, in the previous page. So I will just have to like expand this using the future annuity formula that we do know. I'm just going to take this side, right? So I have 60,000, 1 plus 12% to the power of 6, and I get 118,429. So let's write that 118,429,3611 minus whatever this is. So I will have 60,000, 1 minus 20% to the power of 6. And it gives me 15,000. And it gives me 15,728,64. 15,728,64 is equal to, let's expand this. So we have PT 1 plus 8%, right? The A that we found, the quarterly interest rate that we found, to the power of 24 minus 1 over I, which is 8% in this case. So let us solve that. So we have 118,429.3611 minus our answer, and we get 102,700,7211. So we have 102,700,7211 is equal to, let's find out the value of this. Firstly, let's first store this under B. So this is stored under B. Let's find out what the value of this is. So I have 1 plus A percent to the power of 24 minus 1, right? This is divided by A percent. So this is 30,20 what. So to find what my PT is, I have PT is times 30,2099, right? So let's store this under C. Shift store C. So to find out what PT is, I need to take my B divided by my C, right? So B divided by C is equal to my PT. So PT is actually equal to 3,399,57. So that is the answer for our first question. So they need to make this amount quarterly in order to ensure that they can buy the vehicle that they want to buy, right? So let's move on to the next question. So the next question says a loan is granted at 18% per annum compounded daily. So we have a loan that is granted and it earns 18% per annum compounded daily, right? When something is compounded daily, it is compounded 365 days per year. It is repaid by means of regular equal half-yearly payments. So my payments are half-yearly, and they are 1,500 each, where the first payment is made 18 months after the loan is granted. So the value of the loan is, remember I said in the applications, remember I said in my previous video that the value of the loan is always our present value, right? So let us put this information on our timeline. So we have a loan, right? And we do not know what that loan is. So we have a loan X, right? That is granted at T0. A loan is always granted at T0, but your PV is not always at T0. Your PV is always one period before you started making your payments. So in this case, you are told that you made your payments at T18, right? 18 months from now. So remember that your payments are made half yearly. So you need to take this 18 and divide by 2, right? Which you get 9, right? So you are going to make a payment at T6 initially, T12, right? So you are going to make a payment at T6, right? Payment at T12, and then a payment at T18. Okay, sorry about that, guys. So the payments are made half yearly. So I need to divide by 6, right? So 18 divided by 6 and I get 3, right? So this is a T. This was supposed to be T1. This was supposed to be T2. And this was supposed to be T3. But instead of starting at T1, I started at T3. I made my payment of 1,500 at T3. And we are told that it is compounded. It is compounded half yearly. It is compounded daily. However, my payments are being made half yearly, so I need to calculate my I2. So 1 plus 18,6 divided by 365 to the power of 365 is equal to 1 plus I2 to the power of 2. So my I2 is equal to 1 plus 18.6% divided by 365 to the power of 365 divided by 2 minus 1 times 100. So we have 9,7435 all the way percent, and we will store this under A. Shift store. If you see that there's something under your A, all you have to do is to press execute twice, right? Okay, so this is stored under A. So remember that I said your PV is one period before you made the first payment. So my PV in this case is not at T0, but it's rather at T12 because that is one period away, right? So my PV is right here. So that means I missed one payment because I was supposed to pay at T6, but I ended up paying at T18, right? So I was supposed to pay 6 months from now, but I ended up paying 18 months from now. So I need to move my interest from T0 to T6, T6 all the way to T12, right? So I just need to move my interest 2 times. So at PV, my PV is actually equal to my X, right? 1 plus 8% to the power of 2. Right? Remember, I moved from T0, touch T6 once, touch T12 twice. This is where, remember, I was supposed to pay 6 months from now. That was the condition of the loan. So they can't charge interest for the 6 months, right, before I paid, because they said I can pay 6 months from now. Hence, I did not move this here because you only missed 6 months, right? I mean, the only thing you didn't miss is 6 months, but you missed the other one 2, right? So if you were here at T6, it was supposed like, so you are here at T6, you were supposed to be here at T6, but you are here at T12, right? So you're supposed to make your first payment here at T6, but you made your payment here at P12. So I need to move 1, 2 twice. If I made my payment 2 years from now, I would be at T24. Okay, I don't want to include this here, but let me just bring in another paper. Just need you guys to understand the timeline. So T0, I was supposed to make it at T6, T12, T18, T24, right? So if I was supposed to make the PT here, but I ended up making the first payment here, I was supposed to make it here, but I ended up making it here. So my PV would be one period before, which is 18. So I just need to compound it 1, 2, 3. So I just need to compound it 3 times. So that's what you do. You move to the PV. So in this case, I started at T12 instead of T6. So I'm going to say I started at T18. One period before that is T12. That's where my PV is. So I move this 1, 2 twice. Okay, that's where my PV is, right? That's the value of my PV. Okay, so I had left out like very important information. We are told that the last payment is made exactly 6 years after the loan is granted, right? So we just need to find out what that is. 6 times 12. I will say 6 times 12 because there are 6 years, 12 months in a year. 6 times 12. So the last payment will be at T72. Now I need to convert this 72 to my quarters. So I will divide, into my half years. So I'll divide by 6. So T12. So there are 12 payments in total. So they will be N is equal to, I need to move from where my PV, I need to take where the last payment is, subtract my PV. So 12 minus 2. You always take your half years, right? So 10 in this case. So basically, what I do have is that to get here, to get to T12, I need to compound the x all the way to T12, right? So this is my present value. My present value is equal to x1 plus 8% to the power of 2. However, this PV is also equal to the present value of all my 1,500 until T72. So I will have 1,500 present value of my 10 payments with my 8% interest. This whole thing is actually equal to x1 plus 8% to the power of 2. So let us do that in our calculator quickly. I'll just use the CMPD function. My n is 10, my I is a, my present value is exactly what I'm looking for. My PMT is negative 1,500. Make sure my FV is 0. Solve for PV I mean. So my PV is 9,319. 9,319,2624 is equal to x1 plus 8% to the power of 2. So I need to divide this answer by 1 plus 8% to the power of 2. So whatever answer I got, let's just check. This is the answer I got, right? Divide by 1 plus 8% to the power of 2. So I get 7,736. So my x is 7,737.90. So that's the value of my x. Okay, so let me end this video here. I'll continue with the rest of the questions in another video. Thank you for watching.